In today's video, I'm going to be continuing with the AP Calculus BC syllabus. I'm going to be discussing one of two comparison tests, which is the direct comparison test. So let's see how it works. So it says that if AN is greater than equal to 0 and BN is greater than equal to 0, then we have two specific conditions. So if b to the power of n converges, so if n equals 1, infinity, Bn converges, and An is between 0 and Bn, then n equals 1, infinity, An converges. So in this case, Bn is greater than or equal to An. And then if that's the case, and if Bn converges, then An also converges. So now it's important to know that if Bn is less than An, but if Bn converges, that does not mean An converges. So now let's look at another example. The second condition is if n equals 1, infinity, An. If that diverges, and we have the same condition, 0 is less than equal to An, which is less than equal to Bn, then n equals 1, infinity, Bn diverges. And An has to be less than or equal to Bn, and if that's the case, and if An diverges, then Bn diverges. So now let's look at a few examples of the direct comparison test. So we have n equals 1, infinity. So there are a few steps we need to do while solving this. Our first thing we need to do is we need to choose some other series to compare it to. And in this case, we compare it to 1 over n cubed. So we always just compare it to something without the addition or subtraction or whatever. So in this case, we're comparing it to 1 over n cubed. Now, if we have 1 over n cubed as a series, n equals 1, infinity, 1 over n cubed, we have to determine whether it converges or diverges through the p-series test. So through the p-series test, 3 is greater than 1. So 1 over n cubed converges by the p-series test. So now we know that 1 over n cubed converges. Now we have to find out which one is Bn and which one is An. We know that An should be less than equal to Bn. So whichever one is greater, that would be Bn. So we have 1 over n cubed plus 1 and 1 over n cubed. We know that whenever the denominator is larger, that number would be smaller. So this is An and this would be Bn. And because Bn converges, in this case through the p-series test, so because Bn converges, An also converges. Therefore, we were able to determine through the direct comparison test that 1 over n cubed plus 1 converges. So that's how easy it is. We just have to find one series to compare it to, determine whether that converges or diverges, and then figure out which one is An and which one is Bn. So that's how easy it is. Let's move on to another example. We have n equals 1, infinity, 1 over 3 to the power of n plus 2. So n equals 1, infinity, 1 over 3 to the power of n plus 2. And we have to choose something to compare to. That's our first step. Let's compare it to n equals 1, infinity, 1 over 3 to the power of n. Now we have to determine whether this converges or diverges. Let's use the geometric series test. We can write this as n equals 1, infinity, 1 over 3 to the power of n. Modulus of r is equal to 1 over 3, which is less than 1. So it converges by the geometric series test. I'm just going to write it as GST. Now, again, we have to figure out which one is AN and which one is BN. This is smaller as the denominator is larger, so this is AN, this is BN. Because BN converges, AN converges. So because BN converges, AN also converges. This is because of the direct comparison test. So now let's look at our final example. So we have n equals 4 infinity, 1 over 3n plus 2. We compare it to 1 over 3 to the power of n equals 4 infinity. This through the geometric, oh, I wrote the wrong question. Let me just clear all drawings. I wrote the same question as the previous one. So we have n equals 4 infinity, 1 over root n minus 1. We compare this to n equals 4 infinity, 1 over root n equals n equals 4 infinity, 1 over n to the power of 1 over 2. P is equal to 1 over 2, which is less than 1. So it diverges by the P series test. So this was how we found out whether this diverges or converges. In this case, it diverges, right? So now let's figure out which one is AN and which one is BN. So we have these two things. Obviously, this one would be AN and this one would be BN because this one has a smaller denominator. And a small denominator means a larger number. So because AN diverges in this case, BN also diverges. So that's how easy it is. Okay, that's it for today's video, guys. In today's video, I discussed the direct comparison test. Hope you guys enjoyed and please consider liking and subscribing. Thank you.